Good morning. Welcome to PP1. Today's discussion on the Nyanza Link 22nd edition 2024. Let's get in touch. Subscribe, like, comment, share. Allow me get into the paper. Here comes the paper. You can see it. Welcome to question 1, which reads, a ray of light makes an angle of 50 degrees with a mirror M1. Then M1 and M2 are at right angles to each other. Then you are told, complete the diagram to show the path taken by the ray after refraction by both mirrors. This will take us back to reflection on plane surfaces, where we need to know the laws of reflection, especially when it comes to the incident angle must be equal to the reflected angle. Therefore, for M1, we have an incident angle of 40. We have an incident angle of 40. Okay, can continue. An incident angle here is 40. The incident angle here is 40 degrees, like that. You can see we are having the normal rate, which is there. Therefore, it means that the reflected angle, which must be coming out here, will also be at 40 degrees. Therefore, I'll draw my reflected ray like that. Draw my reflected ray like that. Then I'll indicate that this is the ray direction. That is the ray direction. This now reflected ray from mirror 1 will be now the incident ray to mirror 2. Therefore, I'll draw my normal ray like that. That will be perpendicular to the reflecting surface, mirror 2. And therefore, from the issue of doing mathematics, this will be 40 degrees. This means that it is 50, meaning that this one here will be at 40 then my incident here will be at 50, meaning that the reflected one will also be at 50, 50 degrees. Then I will indicate the way it is emerging out like that. That is now the way to respond to that question. Don't forget that you must indicate ray direction. One must indicate ray direction. Can move on to the next question where you are asked. A positively charged metal sphere is brought near an uncharged metallic object as shown in the figure. Then you are told identify the charge that is at X and at Y. This is charging a body by induction method since the two bodies have not come into contact. Therefore, we expect negative charges to be attracted at X and the positive ones will be repelled all the way at Y. Therefore, I'll just say that at X, I'm having negative charges. While at Y, I'm having a positive charge. If you cannot write this, we still have another option where you can indicate on the diagram that we have negative charges here while we have positive charges here. But if you indicating on the diagram, then you must note that it should give equal distribution. Must give equal distribution. The charge density must be equal for both X and Y, even though they will be opposite. The next question, from one, the student set up the circuit shown below. Identify the error made by the and state how it can be corrected. If you look at this diagram, you'll find that from the cell, you're having an ammeter that is connected in a parallel manner. It is noted that in all circumstances, an ammeter is supposed to be connected in series with the circuit. Therefore, it is automatically that the connection of the ammeter becomes the error made in the setup. Therefore, can say it is wrong connection of the ammeter. How is it supposed to be? How is it supposed to be? How is it supposed to be connected? Then you say should be connected in series to the circuit. Should be connected in series to the circuit. We move on to the question 4, where you are asked, a person standing out in a garden at night is observed to have two shadows. It's observed to have two shadows of different sharpness. What brings about the issue to do with shadows? it is the blockage of a race. Therefore, in this case, we can say that the person is illuminated by two different sources of light. Two different sources of light. If you look at this issue of two different sources of light, then for them to create a difference, the issue of the sharpness of the shadow, then they must be of different intensities, of different intensities. So the first thing is you mention that we have different sources of light. Then you support your argument. What is bringing the different sources? What is the difference between the first source and the second source? And then you can give in terms of brightness. Question 5, the figure shows a copper wire suspended freely between the poles of a magnet. Between the poles of a magnet. Then you are told, indicate on the diagram the direction of the motion of the copper. The first thing in this diagram that you're supposed to show is indicate that the current is moving in this. The current is moving in this direction. From here, then we'll apply the relationship between current flowing in a conductor and it is placed within a magnetic field. And in this case, you're going to use the Fleming's left hand rule. In this case, the first finger, like this, the first finger, this one. This will be showing the direction of the field. This finger will be showing us the direction of the current, whereas this one will show us the direction of the resultant force. Therefore, in this question, we will find that this current is moving in the direction indicated. Therefore, if you apply the Fleming's left-hand rule, then you'll find that at long last, the resultant force will be moving towards the inner side of the magnet. We can move on to the next question. The magnetic field lines between the poles of two bar magnets X and Y are as shown. Then you are told, state with reason which magnet is stronger than the other one. The first thing to consider is the concentration of the field lines. In case the concentration is not considered, then you consider where you have the neutral point being placed. But for this case, you can see the issue of concentration of these rays can be a valid factor to be considered. Therefore, X will automatically become our strong magnet. Therefore, X is our strong magnet. X becomes our strong magnet. It becomes our strong magnet. Now we need to give out the reason. And the reason for this will be, if you look at the X, the magnetic field lines are highly concentrated. And when we say they are highly concentrated, you can say they are very close to each other. Very close to each other. Then now we can move on to the next part, where we have a question where you are told arrange the following electromagnetic waves in order of increasing wave energy. In this case, the factor that is considered here, what attributes to issue to do with energy, is all about frequency. It's about frequency, the one that attributes to energy. Therefore, this one, in order of increasing frequency, Therefore, we start with the one, the smallest frequency, and in this case, it will be the waves. It will be followed by micro waves. We have visible light. We have, then the last one will be remember now, if the issue of indirect of frequency has been mentioned, you're also supposed to be able to show in terms of increasing wavelength as well. In question 8, which reads that the figure below of two identical capacitors, C1 and C2, then C1 is connected to a 20 volts battery. Later on, capacitor C2. Then you are told on the axis, sketch a voltage time graph when Roman 1 charging capacitor C2 and Roman 2 when you are discharging capacitor C1. Therefore, in this case, we should understand that capacitor C1 has been charged to maximum by the battery. The battery is then disconnected so that we can charge capacitor C2. Therefore, we expect that since these two capacitors are identical, that they should share equally this voltage. So if it is from 20, C1 was charged to maximum of 20. Therefore, it is supposed to give out 10 votes and remain with 10. Therefore, we'll start with C2. We'll start with C2, where we have been indicated that we should use uh, uh, if case 2 C1 we have been given dotted line, then C2 we can use a continuous line. Therefore, it rolls all the way, the potential difference rolls all the way from 0 to a maximum of 10, like that. Then we can say that this one is C2. Then C1 will say it was discharged from 20 until it shared a half of its potential difference. And we label that this is C1 that was being discharged. The next question, a lady sees a magnified image of a face in a curved mirror. State two other characteristics of the image. The first to be asking yourself when you are having this curved mirror, is it? Then we'll go for a concave mirror. Therefore, a concave mirror can only form a magnified image. And in this case, since she's looking at herself, we expect this image to be erect or is upright. Therefore, she must be herself between F and the P of the concave mirror. Therefore, we know that a magnified mirror that is erect, then it is accompanied by it being virtual. Therefore, you can say the image is virtual and also it is erect stroke upright. And this is an image that is formed behind the mirror. It's an image that is formed behind the mirror. 10 that reads that one side of a ripple tank is raised and the wave is generated at P. And the wave is generated at P by a finger. After 1 second, the shape of the wave is as shown. Then you are told is not circular. What you should be responding in terms is that we can either talk of the issue to do with change in velocity and change in lambda. Since frequency remains constant. Since frequency remains constant. Then you can say the speed of the wave increases towards side DC. If the speed increases towards side DC, it means that the issue to do with wavelength is also increasing from side AB towards DC. Identify the side of the tank which is raised. It is AB. Then if you raise AB, this is what this one is likely to behave. It will behave in this manner. Meaning that side AB will become very shallow. This is AB, and this is DC. So side AB will become very shallow, and this will tell us that the speed will increase from a shallow end towards the deep end. The same applies to wavelength. It will increase from a shallow end towards a deep end. Question 11. 11. Question 11. A current flows in a wire of resistance R for time t. When a potential difference of V is applied across the wire, show that the total electrical energy converted into heat wire is given by to I squared RT. So work done will be the same as the heat. Therefore, work done on a state current carrying conductor is given by QV. Since we are given in the question to have current, then we should substitute and find the mechanism in which we can get Q and get V. Therefore, we can first say Q is given by IT. Then from the Ohm's law, V is equals to IR. So if we call this one equation 2, and this one equation 1, and this one equation 3, then substituting equation 1, equation 2, and 3 in 1. Then you'll say that work done is given by IT times IR. And this will give you now the I squared RT. Give you the I squared RT. Can move on to the next part where we are having figure 8, which shows wavefronts passing through an opening in a barrier. So you can now see the wavefronts. The way you have emerged as circular wavefronts. If you look at the kind of the aperture, is almost of the same thing with the spacing. Therefore, in this case, we are told complete the diagram to show the wavefronts as they approach the opening. You also understand that you need to know the concept that is being tested. Therefore, the wavefronts that will be approaching this one, you expect them to be parallel and to be of almost the same wavelength. Like that. If you look at this, if you look at that part, if you look at that part, you find that this spacing is almost the same. To indicate the direction in which they are moving in. That is the direction of approach. Question that the diagram shows, or the figure shows, two current carrying conductors placed close to each other. Then you are told, say the type of force acting between the conductors due to the current that is flowing. In this case, we expect these two conductors to have a repulsive force. You can say repulsion. This tells us that current that is flowing the same relay of conductors will bring to us force or an attraction. Set two advantages of alkaline accumulators over lead acid accumulators. The first one is they are very expensive. They are very expensive. So the moment you are buying them, you find that they are very expensive. Number two, which is technical, they have lower EMF per cell. Question 15. Question 15. You're being asked, you're having coil P and coil S in a soft iron rod. Coil P has less number of turns compared to coil S. Then you're told, state what happens to the galvanometer when the switch S is closed. We expect some sort of mutual induction to occur in this case once S is closed. Then, when it is closed, it means that we will be showing that there is flow of current. The galvanometer will deflect. But the question is, how will it deflect? Therefore, the galvanometer deflects to the left and back to zero and back to zero. Set to modification setup to minimize the above effects on the pointer. Deflecting to the left and then coming back to zero. Then in this case, we can separate, instead of using a common soft iron rod, then we can separate the two. Therefore, we can say increase the distance of separation. Increase the distance of separation. That is the first one. The second one, iron rods, remove soft iron rod. Then reduce the number of coils on S. Coils on coil S. Even though once you get a question that is strictly to the number of points, that is exactly what you're supposed to be given. The number of turns in coil S. Then part C, we are being given a transformer which is supplying power to a lamp rated at 6 volts, 24 or watts. Then you are asked if the transformer is 95% efficient, determine the current in the secondary coil. Efficiency is given by the power output over the power input. Multiply by 100, then in this case, you're going now to get 95%. Therefore, say we're talking of the current in the secondary. We have the power already, we have the voltage. Therefore, it will be easier. We say power is given by VI, where we have this one 24 will be given by voltage of 6 times I. Therefore, our I becomes 24 divided by 6. Therefore, our current becomes 4 amperes. Becomes 4 amperes. We're asked about the resistance of. In this case, we can have 3 methods. We can have one. If we use the formula of P is given by I squared R, then our 24 will be given by a current of 4 amperes squared times R. Our R here will be given by 24 divided by 16, 1.5. Option 2. Option 2 can say P is given by V squared over R. Therefore, still our power of 24 is given by V squared. Our V was 6. Our V was 6, which will be 6 squared R. This will lead us to R is given by 36 divided by 24. 5 ohms. Or number 3, you can use the formula of V is equals to IR. Our voltage is our voltage is our voltage is our voltage is 6 6 is given by a current of 4 times R. Our R is given by 6 divided by 4. Still arrive at 1.5 amperes. All those are three methods. Then the last one, the current in the primary coil. The current in the primary, that is the voltage in the primary, is 240. The current there at primary we do not know. Therefore, since we are given the efficiency, we can say the power output S multiplied by IS divided by IP times 100. Now we're supposed to get 95. VSIS, you already have it, but it is 24. Therefore, 24 divided by times IP is equals to 0.95. This making IP the substitute formula. Therefore, IP is given by IP is given by we'll multiply with this. Okay. This will translate to us that is given by 0. Times 240 IP. Therefore, our IP will be the same as 24 divided by 0.95 times 240. Allow me use a calculator. This is 24 divided by 0.95 times 240. We're going to get current of 0.05 amperes. From the input side, because of the issue of emission, we have question 16. We have question 16. Is about the lenses. It's about the lenses. You are taught that it's of focal length 10 centimeters. It is used as a magnifying lens. The H centimeters front of the lens. The image is seen through the lens is 30 centimeters from. Therefore, this case, you are supposed to apply the two key are the two key thoughts or rays. The first ray is a ray that is instant and parallel to the principal axis. A ray that is close and parallel to the principal axis. This ray will be converged at F. Will be converged at F. Will be converged at F. Then you show the direction of the ray. That move in that manner. The second ray is a ray that is passing through the optical center and it goes through and deviated. It goes through and deviated. My rays may not be that much straight, but the key point is you understand how it's supposed to be moving. Then at the point where this will merge, then I will draw my image. You must ensure that the image that you're drawing is perpendicular to the principal axis. Then I would indicate the top in that manner. You are now told in Roman 2, part 1, determine the value h. Proceed to this one. You need to understand since you have formed a virtual image, our V here is not 30 but just negative 30 centimeters. Therefore, using the formula of 1 over F is equals to 1 over U plus 1 over V, then 1 over 10 1 over 10 is equals to 1 over U, which is our H now, plus 1 over negative 30. 1 over H, if you make it the substitute formula, then it will be 1 over 10 plus, since this one is at negative, then once it goes to the other side, it will be at positive. Then over 1 over that. This will lead us to LCM. This is 30. This is 3 plus 1. Then our H is equals to 30 divided by 4. We arrive at 7.5 centimeters. We arrive at 7.5 centimeters. And now you are asked width of the image if the object is 10 millimeters. Width. In this case, I am going to use the formula by U, also given by the age of image over the height of objects. And now I can proceed and say that 30 out of 7.5 is the same as the E over our HI will become 30 times 10 divided by 7.5, and we'll arrive at 40 millimeters. Thank you so much for taking us through this part 1 or section A. Thank you so much. May God bless you. In case of inquiries, you can always have to reach me through 0757 019011. Have a blessed day. Thank you so much.